Okay, so now I will be going over question 3. So the important concept to look at question 3 is angular momentum. Okay, the definition of angular momentum is a quantity of rotation of a body which is the product of its moment of inertia and its angular velocity. So how we represent angular momentum is with an L. There are two types of angular momentum. The first type has the equation angular momentum equals I, which is moment of inertia, times angular velocity. This is supposed to represent an object rotating around an axis or around its own axis. So the object is just rotating around itself. So I'll just draw an example. Say like this ball is just rotating around in a circle. And then there's another type of angular momentum, and that's when an object is rotating around something else. So a easy example to think of is the Earth rotates around the sun, and that we do L, or angular momentum, is equal to mv times r. And so the m stands for the mass, v is the velocity, and r is the radius, or how far the object is from what it's rotating around. Okay, so in this problem, we are going to be using the angular momentum equals mvr type. So we'll just circle that, but this is the other type. Okay, so now I'm going to read the question. A particle of mass 2 kilograms is moving in the xy plane at a constant speed of 0.8 meters per second in the positive x direction along the line y equals 4 meters. As the particle travels from x equals negative 3 meters to x equals positive 3 meters, the magnitude of its angular momentum with respect to the origin is. So first I'm going to draw a picture of what's happening. Okay, so I'm just going to draw right here, right below. So this x and y, and it's traveling from negative 3 meters to positive 3. So this is the object traveling, and it is 4 meters above. So in this problem, it is asking to find the angular momentum of this object traveling. So we're going to be using the angular momentum equals mv times r. So I'm going to put here L equals mv times r. So first, m, so the mass of the object, and they give us that the mass is 2 kilograms. I'm just going to put 2 there. Then for the velocity, they say that the velocity is going at a speed of 0.8 meters per second. And then finally, the radius, since it is 4 meters above from the axis of what it is moving across, that means that the radius from the axis of rotation, and as you can see in the problem, it's moving it says with respect to the origin. So we can know that the 4 meters above, that means how far it is and what the radius is in this problem. And so then we put 4 here, and then if we calculate that, we will get angular momentum is equal to 6.4 kilograms per meter square per second. And that is answer D. So that is the answer to the question. So in conclusion, this problem shows an important concept of angular momentum, and specifically angular momentum of an object rotating around something else. And we can calculate that because they give us, with respect to the origin, how far above it is from the origin, So that shows us our radius, they give us how fast it's traveling, and they also give us the mass of the object, so we can easily calculate the angular momentum.